Dear students, we were discussing about some definitions in thermochemistry. Today we will discuss about lattice energy. So remember that lattice energy is used for ionic compounds. It is the amount of energy released when 1 mole of an ionic crystal lattice is formed from its components, gaseous positive and negative ions, or it may be defined as the amount of energy required to break 1 mole crystal of an ionic compound into its components, gaseous positive and negative ions. Whenever 1 mole of an ionic crystal is formed, the amount of energy released in this process, or whenever 1 mole of an ionic crystal is broken down and the amount of energy required to break this 1 mole of crystal into individual ions, it is called as lattice energy. Now lattice energy is denoted by delta H with a small l, and the units of lattice energy are same as the units of heat of formation, combustion or neutralization, that is kilojoule per mole. Now this lattice formation energy and lattice dissociation energy, they are always same but with opposite signs. For example, if we take the lattice energy of formation of sodium chloride, there is two individual ions, sodium ion and chloride ion, they combine to form sodium chloride. Like this is sodium gaseous ion, chloride gaseous ion, they combine to form sodium chloride. Now energy will be released in this process because this is the formation of sodium chloride. Now this type of energy will be called as lattice formation energy. On the other side, if we break this 1 mole of sodium chloride into its individual ions, that is sodium chloride is broken down into individual ions. Now energy will be absorbed in this process, and if you see, the energy absorbed is equal to the energy released, and with both are same but with opposite sign. In one case it is negative in the formation, and in case of breaking it is positive. Now lattice energy depends upon the charge density of cations and anions. Charge density is defined as the charge per unit area. Now greater or higher the charge density of cation and anion, higher will be the lattice energy. If we take the example of lithium chloride and sodium chloride and compare the charge densities, so in both cases we will come to know that the charge density of lithium chloride is greater than the sodium chloride. That's why the lattice energy of lithium chloride is much higher than that of sodium chloride. For example, the sodium chloride is, the lattice energy for sodium chloride is 770 kilojoule per mole, while it is 831 kilojoule per mole for lithium chloride. Why? Because the lithium ion have higher charge density than sodium ions. Therefore, there is greater attraction between lithium and chloride ion as compared to sodium and chloride, and when there is greater attractive forces, so lattice energy either in the form of formation, either in the form of breaking, it will be greater than those in which the attractive forces are less. So it depends upon the charge density. Remember that it is dependent on the charge density of the ions present in the ionic compound.